Okay, this is Unit 4, Topic A, Topic 1A, Chemical and Physical Change. And if you haven't seen my last video, I started Unit 2, and upon further investigation, since the majority of my audience goes to McKeel and the AP Chemistry course is not following the traditional course guidelines, unfortunately, I'm just gonna have to do it this way. If you go to another school, I'm sorry for the inconvenience. I would like to teach it how AP designs it because it makes more sense to study individual compounds and substances before you go into chemical reactions with different species. So sorry if this disorients people. I'll probably just private that Unit 1 or Unit 2 video until we can get back to it, because I want to make sure that no one's getting tripped up or confused. But yes, so if you go to McKeel, this is breakpoint 3. We're starting Unit 4, Topic 1 on chemical and physical changes, which goes into our big unit of chemical reactions and what that involves. So first, let's talk about a physical change. So if some aspect of the physical state of matter is altered, but the chemical composition remains the same, then the change is considered to be a physical one. So, say we have some ice that turns into liquid water. We're going to have a melting, which is just a phase change, which is equivalent to a physical change. Condensing from a gas to a liquid on a water bottle, for instance, on a plastic water bottle, you get a physical change because the substance hasn't reacted with any other chemical species, right? If we look at like some I2 crystals, some iodine, you're going to get a sublimation, so that's going directly to a gas. You can also get this with dry ice. So that's a chemical change when the substance, this compound, isn't altered at all. But how do we differentiate between the types of physical changes? So in solids, the particles have relatively low energy and vibrate around fixed positions. So solids have the lowest energy out of the 3 traditional states of matter. And if a solid is heated, then particles gain energy, move around more, and eventually gain enough energy to break away from their fixed positions and form a liquid. So if you think about heating ice, that's going to start to melt and break away. I always think about water because it's just the one that we're most comfortable with. It's going to start breaking away and turning into liquid and boiling at some point. And then if we continue to boil that, we're going to get a lot of energy and enough to break away from one another and form a gas. The gaseous state is the highest energy, so the most energy here, and the least amount of energy in the solid phase. So yeah, they move freely and with relatively large amounts of energy. They're bouncing all over the place. They're bouncing off the walls. So in a chemical change or reaction, the atoms of the substance are rearranged to form new substances. Right, so chemical changes require that the new substance or substances have a different chemical, and then we're going to say composition, right, which means it's made up of different stuff, essentially. And then this is often accompanied by observable changes, that things we can see with our naked eye, like color changes and energy changes, which sometimes is also states of matter, so I wanted to highlight that as well here. So some types of chemical changes that can occur, some evidence is a color change, energy change, formation of solids or a precipitate. We'll talk more about that word soon. Formation of gas, which means that something's coming off of the compound. If you didn't have gas before, now you do. Something's coming off of it, so the species is being altered. And then we can observe an electrical current, which we will talk about more in a few breakpoints. So yeah, these changes are sometimes called driving forces, but you don't really see that as much. So let's talk about some gas-producing reactions, because that's a good indicator of a chemical change. So if we have an acid and metal, like nitric acid, and let's just say silver, oh, and this it's hydrochloric acid in this example I gave. So if we have hydrochloric acid here and some zinc metal, it will form a salt, which is just a type of compound. It's just a type of compound. The salt here is zinc chloride and hydrogen gas. And how do we know that this gas is here? Because a lot of these are odorless, colorless gases. We can tell because this will make a popping noise on a lit splint, which just means we lit a piece of wood on fire. So that's our example there for hydrogen. If we have a carbonate, so CO3, sodium bicarbonate is baking soda. So if we have this acid and carbonate form, we'll get a salt like we saw before. And instead of just getting one gaseous product here, we're actually going to get water and CO2. And essentially, this is going to be one product at first, and it's going to break into two products. So it's what the water and CO2 are carbonic acid at first, and then they break down, and we'll look at that in an example. So how to test for this gas: it extinguishes a lint split CO2, and so this is our sulfuric acid plus calcium carbonate, and it yields this carbonic acid and this salt, the calcium sulfate. This is our salt here, and so this has to be our gas. But wait, this isn't the gas, this is an acid. So yeah, this gas will break down, as we can see here, and form CO2, which is what we wanted, and also liquid water. Also note the state symbols, right? We're going to talk more about this when we get to net ionics in the next video. But we have a solid, an aqueous, which means we're in water, aqueous, and then this produces water in the liquid state. The only time we ever put L is if something is in the liquid state by itself and not suspended ions in solution. And we'll get more into that when we cover net ionics. So then lastly, we just have oxygen. It's the same as the other two. It's just gonna relight a splint. So that's how we know that we have oxygen gas, and this is just a peroxide breaking down into water and O2. So let's look at a couple of practice problems real quick. So predict what gas is produced when HCl and zinc are combined. Write the balanced equation as your answer. Okay, so we have HCl plus zinc, solid, and this is in the aqueous form. So we know that zinc always has a charge of +1, so it's gonna form with the chloride that we have, this negative anion, and we're gonna zinc chloride plus H2, but we only have one H on this side, so we gotta pop a 2 out in here. That makes it 2 chlorine, so I'll have to put a 2 on front of this chlorine, and then we only have one zinc over here, so we're just gonna put the 2 over there. And if this was a more complicated one, I'd do a reactants and products chart, but since we only have 3 species here, it's pretty simple. So we'll check, they'll make sure. So we have 2 hydrogens on this side, 2 hydrogens on that side, 2 zincs on the reactant side, 2 zincs on the product side, and then 2 Cls on both sides, so we're good. And then predict what gas is produced. We'll just highlight and say H2, and we'll notate that by saying we're in the gas phase, and this will be a solid, and we'll talk about how we know that's a solid again in the next video. So as hydrogen peroxide decomposes, we just talked about this in the notes. It's just going to relight a splint. That's how we're going to know. And this is a balanced equation here. 2H2O2 yields 2 waters plus O2 gas. So let's write the balanced chemical reaction between phosphoric acid and magnesium carbonate. And why does this result in 3 products instead of 2? Okay, so we always start with what they give us in chemistry. It's usually the good rule of thumb. This is an acid, and then also a salt. And these are polyatomic ions, so we know their charge. If you're not familiar with your polyatomic ions and haven't memorized them, I highly recommend it, because unlike in class we don't get a polyatomic ion sheet on the exam. Okay, so we know that the anions have to bond with the cations, and the cations have to bond with the anions. So we know that this magnesium is going to bond to this phosphate. There we go. So phosphate has a charge of 3 negative right here, because we know that because hydrogen has a charge of +1, and there's 3 of them, and there's only 1 of this phosphate group. So then we're gonna know that this has 3 and this has 2 because our magnesium has a charge of +2, and so the least common multiple is 6, and this is gonna be aqueous, and then we're gonna have our H2CO3 because carbonate has a charge of -2, and hydrogen always has a charge of +1, do aqueous, and then we're just going to balance real quick, and say we have 3 hydrogen this side, so 2 here, 3 here, we have 3 CO3s on that side, okay, and there we go. And then, whoa, but wait, we just looked at this, the carbonic acid, so this is actually going to break down into H2O plus CO2, and this is going to be a gas, and remember, pure water is a liquid, not aqueous, because it doesn't have anything in it. And so then we're going to make sure that we're actually right with our coefficients. Let's see. Oh shoot, once we see that we have this species, we don't actually need these coefficients anymore, and we should be good to go. And that is our reaction, and we know why it produces 3 products instead of 2, because carbonic acid breaks down into water and CO2 instantly. Okay, I know this is kind of a longer video, but I wanted to make sure that we understand the principles of this unit, because this unit is starting to get into some pretty difficult stuff and not just stuff that we know from Chemistry 1. So let me know if you guys have any questions in the comment below, and make sure that you like and follow for more.